Welcome to the second tutorial of the Digital Fabrication Basics seminar at the Digital Design Unit. In this tutorial we will take a closer look at possible surface connections and will prepare our file for laser cutting. For this we will edit a more complex geometry. The geometry is based on a project by Andrew Kudless. The project is called Honeycomb Morphologies. We will provide further content and a lecture so you can learn more about the project. We will now start directly in the Grasshopper file prepared for you, which we will now go through together. Okay, for the inputs it should be noted that there are two different methods. We are currently testing both methods to ensure that your geometry is buildable, and if a method doesn't work properly, we will let you know. Various curves can be generated in Rhino for the input. For example, like this here. And I will enable the preview. We start with the second method to explain what we are doing. Okay, and I will right click and clear the values so you can create curves in Rhino. Select multiple curves and then start from the top and select the curves in the right order to the bottom. Now we can see that our geometry works. We can also test closed curves, multiple curves, and this will also work, but this only works with the second method, because here we use the normal vectors to extrude the points. When we are using the first method, which we can adjust here, then we can see that the geometry is broken on this part and on this part. It's because we only use one vector, which is this one at the moment. We can change the line right here by right clicking and set one curve, and we can change the curve right here when we move a point of the curve. We see that the vector is adjusted, but the closed curves only works for the second method. If the second method I just mentioned is possible, then we are able to loft more complex or even closed curves. Horizontal or vertical components can be created. As in the example by Andrew Kudless, two walls can be created next to each other that support each other. If you want to create the geometry from two parallel walls, it's important that the second surface is flipped, so that the normal vectors are pointing in the other direction. This allows the input curves to touch without the output geometry eventually intersecting. So I will continue with these curves right here, set multiple curves in the right order, and we are able to adjust this curve directly in Rhino, and we will continue with this input. Here we can see that we generate a lot of points on the surface. We can adjust the UV count here, and here you can change the amount of cells. So we are generating a lot of points on the surface and receive also the normal vectors. We can display them. Here the vectors are small, so we can use the amplitude component. So here we can see that we have a lot of normal vectors and not just one direction. With these points on the surface, we can now create different patterns and grids. In order to be able to assemble the geometry, stripes are created that follow a specific pattern, and we have reconstructed this pattern here. So here we create the stripes. You can also take a look into this component, and here are these stripes as curves. And afterwards we can unroll these stripes. So we have reconstructed this pattern here, for example, by dividing all these points into even and odd columns and are filtering the correct indices right here. In this section, it's only important that you set your desired number of cells right here. And here below, the vectors are edited, and you can switch between method 1 and 2. If you want to use method 1, you can import a line here that indicates the vector direction. And for method 2, the vectors above are automatically generated by the surface. You can also use an attractor points to modify the component depth with a point. If you want, you can also create the attractor with a curve. You will probably only build a few cells for the task, but for your digital presentation, feel free to try out more complex shapes and more complex attractor logic if you like. That's all you need to know about the creation of the geometry. Here is the output, so this section, and we move further. In this section, a few points are generated and prepared on the three-dimensional geometry so that we can unfold the points with the surfaces as in task 1 in order to finally be able to arrange the attachments. Here you can adjust the markings. You can see them right here. Please check if the text is correct. It should be such that all markings point in one direction. So this text points in this direction, this text points in this direction, this one in this direction, this one in this direction, this one in this direction. And the labelings should face down. Here, these ones should face down, and the others should face up. It may also be the other way around, so keep that in mind. And the text will help us for the construction, so we can orient how we have to fold these stripes. Yeah, so we can adjust the labeling. Here we can also display the external surfaces, but we left them out as not to complicate the workflow. And you can also display the geometry as for the Arctic mode. Or hide the whole geometry. And you can also display the dimensions. You can also adjust the size of the dimensions. If you want to scale the geometry, just select all curves and points and scale the geometry directly in Rhino. In the next step, we will unfold the stripes. For this, we activate the switch right here. And very important, make sure this switch is off if you want to edit the geometry again on this side. So if you want to edit something here, just consider that this is set to false. Now we will run the folding process. We double click, and now the whole geometry is unrolled and also prepared. So if you have a powerful computer, you can leave it on if you like, but to keep the file from crashing, I recommend it. Here I have provided a Python script so that you don't need an add-on. You can use this for your own projects. Here you can customize the layout. So for example, the spacing. If you have a large geometry, I recommend to just type in the values instead of using the slider functionality. And here below you can select different paper sizes for orientation, or select the size of your laser cutter. This is the size of the small laser cutter at TU Darmstadt. Note that a distance of 10 millimeters, I think, to the border must be maintained. The inner rectangle, here the green one, the offset is used for orientation. And make sure that your Rhino file is set to millimeters. You can go to File, Properties, and under Units you can check. In the next step we will take a closer look at different connections. The easiest way to connect the stripes is by gluing. So if there are difficulties with connections, the stripes can still be glued. Pay attention to the instructions for the task on Moodle, or ask if you want to glue the surfaces together. Now I will show you how you can operate with these components right here and create your own version. I will just create point and curves components. And connect these so now we can work with these components. Here we have the boundary curves for these stripes. If we want also to adjust the stripes above, we can use these components right here. But for now I will just explain it to you right here. Overlapping, so I will adjust the layout option right here. Oh no, I think just the boundary is not in the right position, so now it works. Here it's overlapping, so we have to scale the geometry down a little bit. Just a little bit. Okay, this should be fine. The geometry is inside our rectangle. Okay, this works. Here you can adjust the layout. And now we can work with these components. Here we have the boundary curve. We have our points, and for every point the respective edge. So we can work with the edges, and we can, for example, create an opening for a screw just by using a line component, connecting these 2 points together. Then we receive a lot of curves, a lot of lines. Can use curve middle to receive the midpoint. use a circle component. So now we receive for each face an opening for a bolt or a screw. This is one possibility. Or we can use evaluate curve. Get points on that curve. So this is our line. For example, 0.8 and again now 0.2. Then we receive 2 points. If it isn't working, you can right click on curve, on the curve input and reparameterize it. So the curve has values from 0 to 1, like this, 0 and 1. To be on the safe side, you can reparameterize this line. 0.8 and merge all these points and create circles. So this is also possible. Then we have 2 points per face. Or we can also use these edges right here. I will bring them down. So these are these 2 curves. We can use them also with evaluate curve, modify them. So now we have 2 points on one edge. Can do exactly the same for the other curves. And now we need to move these points towards the center of the face. Therefore we need a direction. And here we got a line. So this is our direction. And we can use this. We connect this line to a vector component. So we receive this as a vector. And then we can unitize this vector with the component unit vector. And use the amplitude component and type in some values. Then we can move these points with this vector. Also the other points. And here we can see that the point is facing outward, the point is outside of the geometry, and we want to bring it in the other direction, so we use the reverse component and flip the vector in the other direction. Test it for this point. Yeah, here we will also need this. And so we can merge these points and create our openings with circles. And now we receive 4 openings and can adjust the position. So here you can prepare your own versions, can collect all the curves you want, for example the boundaries. And for this versions up here, these are the boundaries. But when we want to use openings, we don't need these parts right here, so we use these boundaries. Then, for example, this curves or these curves. And afterwards we can bake them. So, welcome back. Sorry for this shortcut, but we have tested a few things and have new information and gained new knowledge. And so this part right here, you can ignore this and we will eventually remove this from the script. And here you have created your own connection parts, and maybe we will add additional informations and helpful stuff in this connection section, so that you don't get confused why we have here such a big section and didn't mention it. So yeah, it could be that we will eventually leave this out or remove it. At the top view, you can see that here are brackets generated and also on the stripes. And we will disable the preview of these curves. We will disable this. So we will work with these boundary curves right here. And now we need to create our connection parts also for the other stripes. So I will just copy and paste this here. And now we need the boundary curves. So the first curve component is for the boundary curves. So we need to find them. Here we used these ones. So now we have to use this component and connect it to this here. And now we also have the boundaries for the stripes above. And also need to connect these here and these 2 point components. So here these two are the point outputs for these components. And now we need the second point output. And now we need our curves, which are these 2 outputs. And now we created the openings also for this path. So now we have to check our openings. We can use screws or bolts like M3 or M4. So M3 for 3 mm and M4 for 4 mm. But these are radius inputs. So we need for 3 mm 1.5. Change the slider setting. So for 3 mm screws, we need 1.5 mm, and for 4 mm screws, we need 2 mm. And we will use one slider for every component to be on the safe side. So now we can check, for example, 1.5 mm. And here we can see that our geometry is not suitable for this case. We can also try only these ones. But we also have to check if the cell size, so when we take a look at the 3D geometry, if here is enough space to connect these 2 parts with screws or bolts. So we have to check this, and if here's enough space in these cells, we need to scale this geometry up, or we can also decrease the amount of cells. So now we have to change our layout a little bit. So the spacing. And afterwards we can also bring them closer together. And you have to keep in mind that the screw is a little bit larger than the opening. So from the opening to the folding edge, it should have enough space. So before exporting, we will take a look at our dimensions and measurements. You can go to this section before unrolling and activate the dimensions with this component. And these are displayed in millimeters. So now, for example, we want to scale the geometry. So we select everything, type in scale in Rhino, type in 0 for the origin and press enter. Then we can scale the geometry up. And we also have to adjust layout. So we have to adjust the slider components. Increase the distances. So afterwards we can bring them closer together, but for now it's okay. And when we are scaling the geometry, we also have to adjust the component depth. So we can do this at the beginning, here at our settings for the attractor point, and increase these values. I also adjust these values for the laser cutter at TU Darmstadt, which is 1000 by 600. Then we will bake it and bring them closer together. So if you are happy with your connection results, you can collect all your curves. So these are the boundaries. These are the other boundaries. And then we need our connections. For these connection size, 1.5 millimeters, we can use 4 openings instead of 1 per face. So these ones. And we can hide these ones. And also for the upper ones. Then we can collect these curves. So here we have our connections and boundaries. We can hide this part. In this case, I will adjust the openings, so the T parameters, to 0.75. Here also 0.75. And for the second ones, 0.25. And also adjust the amplitude and bring them more inside. For example, 8. And I will use this value also for these ones. So they are the same here and here. If we are happy with our results, we can use these curves, bring them here to the other output curves. Here we have our perforation for the folding edges. And we can increase the size of the text in this case. So we go to this section and increase the size. Oh, here it's not working. We can change the position. Okay, now it works. It can happen that a stripe has no tagging, no text. If this is the case, you can right-click on the Grasshopper canvas and press Recompute, and then it should be working. So we have here our output geometries. So now we want to export all these curves, and for the laser cutting we need a specific layer structure. Here it's prepared. You can find more information on the Modellbauwerkstatt website by TU Darmstadt. Here is the online store where you can upload your file, and here is a PDF file where you can receive all informations. The first curve we need is the boundary, which is this one. It's called Laserjobrahmen in German, and make sure to set the color to white. And the values are 255, 255, and 255. We can find it right here. So this is the outer one. So we right click on this component and bake it to Laserjobrahmen. Here you can see that the color is white. Then we have a layer for vector engraving, so vector gravur hell, which has the color red, so 25500. And there we will bake our text. So we have to find it. It's this component. Right click, bake, vector gravur hell. And for the next layer, vector engraving darker or deeper, it has the color blue, so 00255. And make sure that these numbers are set correctly. For this one, we have no specific curves, so we will leave this out. And for the fourth layer, we have a vector cut for the inner edges, so Vektorschnitt Innenkanten, which has the values 0, 255, 255, so Chayan. Here we will bake the openings, these curves, bake them to Vektorschnitt Innenkanten, and also these ones, bake Vektorschnitt Innenkanten. So the last layer is vector cut outer contours, so Vektorschnitt Außenkonturen with the color green, so 02550. And here we will bake the outer contours or boundaries and also the folding edges. So these two components, Vektorschnitt Außenkonturen and also our perforations, so our folding edges, bake Vektorschnitt Außenkonturen. So now everything is baked. We can hide this stuff right here, except the inner boundary. So we use this as a reference. Everything should be inside this boundary. And we can lock this, this first layer, Laserjobrahmen. So now we can move these geometries. We can select them from left to right to only select all these curves that are inside the selection. And also these ones. And here you can see that this curve is not selected because it was not inside the selection. We can press the Shift key and select all these curves, and then we can move them right here. Now I bring one after the other together. So I press the shift key and select everything from this stripe. Bring this component down. Then this one. Make sure that you select everything from the stripe. So now we can enable our laser job RAM, so the outer boundary, and we can close Grasshopper for now. These are our curves. We will select all and go to File, Export Selected, and export our drawings. Now we can open our exported file. We can also select everything and type in Move. Select the first corner right here, type in 0 and press Enter. So it's at the origin, and then we can save this file again. So this is the file for the laser cutter workshop, and you have to check here all layers and make also sure that these layers are set to hairline. So every layer should be set to hairline. Then save your file. And also make sure to save your other Grasshopper file and other Rhino file with these curves right here, so that when you will assemble this geometry, you can orient on the markings right here and know in which direction you have to fold. This is very important. Don't forget this. And name all these files similar so that you find which file belongs together. Here you can also see that the text is flipped or upside down. This is not a problem, but you have to keep that in mind. So this is a little bit confusing. This text is facing upwards, but in this direction. And then this text is facing downwards, but also in this direction. And then again, this text upwards, but in this direction. And this text downwards in this direction. This text upwards in this direction. And this one again downwards, and so on. So this one right here is a little bit confusing. But if you take a look at the 3D geometry when you are assembling your geometry, it should be possible. Now your file is ready for production. It is also very important that you pay attention to the folding direction. If you make a crease in the wrong direction, the respective strip will be broken and will have to be produced again. Therefore, take a close look at the three-dimensional geometry here and pay attention to the text marking for orientation. You can also create a folding UT for your geometry if it's not overly complex. It is very important that you work carefully here and fold in the right direction. Feel free to ask us any question if anything.